Talk a little bit about foaming, theories regarding foaming, discuss this current $1 million IPPA funded project, and a little bit on some precautionary measures. So basically it's sort of understood that three things are required for foaming to occur. Number one, you need some kind of gas generation going on, methane, hydrogen sulfide, etc. You need something that reduces the surface tension of the surface. And what that essentially does is it allows a bubble to start to form. It elasticizes that surface. Then, once a bubble forms, you need something to hold it in place, kind of like a support structure, like a dome. And there's some theories on how that takes place. A little bit on surfactants. Surfactants allow stretching of the liquid surface, and these can come from a variety of sources, detergents, oils, grease, or biosurfactants, which are actually produced by bacteria. So either way is a source for surfactants that allows the surface to at least allow itself to form a bubble. The interesting thing about how to get rid of foam then, after the fact, is to find something with a product with a much lower surface tension that then essentially rips the foam apart. Okay? More on foam support. For foam to persist, it must be supported somehow. This support can come from what's called filamentous bacteria. So there's been quite a bit of research looking at foaming manure and the bacteria colonies that exist there. And there's this special class called filamentous bacteria. They also will produce a surfactant on rapid growth. Or a foam bubble can be supported by fine fibers of some kind. So don't worry about these words here. I still can't pronounce them. But just to give you an idea, these filamentous bacteria, they form and they basically look like strings. And they essentially allow support for foam itself. So fairly interesting bacteria. Infield foaming. Basically, the first slide here is 4 foot of foam in this case, just coming up through the slats and then well into the animal zone, that next picture there. Okay. Pump out foaming at the pump out location. Chuck has some nice video for you to give you a better feel for the consistency of the foam that we're seeing. I think we've all heard and we know the potential consequences of foaming. The consequences range from partial damage to complete barn dismantling. So it's a serious business, and we're working hard to try to solve this problem. Some things about foaming that makes it complicated, to be honest about it. Has occurred in one pit of side-by-side rooms with equalizing channels. Right? Same genetics, same everything. One side of the building foams, the other side doesn't. Commonly found in one barn to multi-barn sites with common genetics, feed management, etc. Attempts at correlating foaming versus non-foaming barns with multiple factors has been elusive. So we, of course, have tried to take surveys, trying to figure out foaming versus non-foaming barns. Give us all the information you can. Is there something that correlates between the two? And quite frankly, we have yet to uncover the root cause. General avenues being pursued. So here's some of the things we're looking at. We've got a project, as you know, going on with, we're looking at either some microbial cause of foam or chemical cause of foam or some combination of the two. Is it a bacteria population imbalance or is there some chemical imbalance going on that we have yet to uncover? Current research suggests a little bit of both, and the role of DDGs being investigated but far from conclusive. Okay? So let's talk a little bit about this project we have funded. Goal, finding and correcting the root cause of foaming. Bottom line. We're not trying to come up with Band-Aids. We're trying to come up with the root cause and try to solve this problem. So let's talk about this project a little bit. It's a multi-state effort between Iowa State, Minnesota, and Illinois. We have 20-plus academic professionals with expertise in manure management, chemistry, microbiology, feed rationing, feed rations, and digestibility. All right? Iowa pork producers, $1 million over 3 years. Very substantial investment. Very serious effort here. We're 6 months into this research. Project managed by Iowa State. Our team is working diligently to solve this problem, and I'm confident that we will. We have project oversight by some very important people out there in our industry. I'm just listing those here. You'll have an opportunity to see these slides as well on IPPA's website. Project status, I guess what's really important, about a year ago we started talking about this project, and then as of September we started working on, the 3 universities started working on this project. It's a 3-year effort. We will keep you posted with through avenues like this or through printed material through IPPA. Multi-state research, so we have all 3 universities working together. We're, for example, Iowa State's looking at some feed trials, doing some chemical composition analysis, looking at methane production potential, and a little bit on foaming potential as well. Minnesota, extensive producer survey. Chuck will talk more about that. We're trying to get to as many producers as possible, and we really, really encourage your participation in this survey. You're part of the team. Microbial analysis is also being looked at Minnesota, and they have developed a kind of a foaming index, if you will, so we can take manure and see, even though it may not be foaming, is there a potential for it to foam? And so we're looking at that, and that's been developed, and we're using that in our research project. Illinois, they are organizing all manure sampling, so they're collecting lots and lots of manure samples and then distributing it amongst all of our researchers, so we all have common samples from which to take all of this information from. A little bit, one slide on each university here. Iowa State University project, one of the PIs is here, Dan Anderson in the back. But basically they're busy in the lab looking at things like methane potential in this case is a function of, or production potential. This case is a function of temperature. Bottom line is they have lots and lots of foaming manure in the lab as we speak. University of Minnesota developed and is managing, as I mentioned, an extensive producer survey, and I really encourage you to please participate. There's an online version. Dr. Clanton will talk about that. He also has hard copies here for you to take as well. And we're in full force trying to get this survey out. University of Illinois. So over some of the initial research that they did, they have found some interesting microbial differences between different transitional ranges within a typical deep pit. And so they're going through great pains to do collections in those 4 different 4 levels, and then all of that information is being sent around to all of our universities. So far they've looked at 76 barns in about the last 2 or 3 months. And the researchers are evaluating on the order of 250 samples, just scratching the surface right now in terms of what's going to be collected and analyzed. Precautionary measures. So here's the bottom line, right? Any attempt to break up foam will release explosive levels of methane. That's for sure. Therefore, all ignition sources need to be off if there's any attempt to break up this foam. People vary on recommendations for the ventilation required, but certainly 30 cubic feet per minute per space in the barn. And that can be achieved through your fan and inlet system or on a nice windy day through your curtain system. And this 30 CFM per space in a 1,000-head barn is equivalent to about 2 48-inch fans, 3 36-inch fans, or 6 24-inch fans, just to give you a feeling. I'm going to let you look at this online, but bottom line is there's different strategies for making sure that we're ventilating our barn at acceptable rates. And again, this will be available on the website so you can take a better look at it. I think one of the important things is as follows. Methane trapped in foam has been measured to be on the order of 70% methane. That's 700,000 parts per million. The explosive level of methane is on the order of 5%. Okay? So obviously, if we have trapped gases at this level, we need to provide some dilution potential before we ever consider breaking that up. So just to give you an idea, at roughly, for a 1,000-head barn at 30 CFM per space, it would take about 6 minutes at that ventilation rate to reduce that concentration in the barn from about 70% down to or below the explosive level. Okay? And just some other information there for you to digest later on. Precautionary measures, so there's lots of information out there, a lot of good information on what to do when dealing with foam. National Pork Board has some really good information. Iowa State has some very good information. IPPA has some very good information, as well as the University of Minnesota. So I would encourage you to take a peek at these sites to get a little bit more information on what's going on here. Foam forms, now what? So I put this on here just to give you an idea. So if we look at a forming foam bubble, if you will, it's really caused by one of the three legs of cause is a reduction in surface tension. So something is providing a reduction in surface tension. And research has shown that if the surface temperature or surface tension reduces to about 60 relative to pure water at about 72, foam will form. So what makes a good defoamer? I mentioned it earlier, but what makes a good defoamer is something that has a much lower surface tension than that because it essentially rips the bubble apart. So I'm just listing some things here that think of a good lubricant. A good lubricant is also a really good surfactant. So if I could buy a bunch of WD-40 or a liquid wrench, I could break up foam, right? Just to give you a feeling for what is required to do that. And I'm showing you some commercially available defoamers in terms of their surface tension and some other information up there for you. Still, the root cause needs to be identified.